And welcome to our channel Concept in Mechanical Engineering. Here we will study the entire syllabus of mechanical engineering, which will be helpful for your semester examination, GATE examination, IS examination and other competition examination. First we will start with the most important and interesting subject of mechanical engineering, which is thermodynamics. So first we will see the marks distribution of thermodynamics in different examination like GATE and IS. Then further we will study the entire syllabus of thermodynamics. So first we are starting with thermodynamics. As we can see, if we classify thermodynamics, that is marks distribution of thermodynamics, in two broad examination, that is GATE and ESE, which was also called as IES examination. In GATE, it is asked for 4 to 5 marks, and IES we can classify it into two categories as per objectives and conventional paper. If we see an objective, it is asked mainly for 20 to 24 marks, and in conventional paper it will come up to 20 to 22 marks. If we consider GATE, then if we consider thermodynamics, and applications, it is asked for 12 to 13 marks. In this includes basic thermodynamics, RAC, that is refrigeration and air conditioning, IC, engine, internal combustion engine, and power plant. If we analyze GATE 2022, we see in shift 1 they have asked 3 marks questions, and in shift 2 they have asked total 5 marks questions from thermodynamics. Only from thermodynamics, that one, only this basic, I'm talking about only this basic, they have asked these questions in GATE 2022. If we come for IS examination, so ESE prelims, (2022-2021). In 2022 they have asked 10 marks questions, and in 2022 they have asked 24 marks. If we come for ESE mains 2021, they have asked 22 marks questions. This is the marks distribution of thermodynamics in these two examinations. We will later discuss on different examinations also. Now we will start with the basic concepts of thermodynamics. Thermodynamics. It is the branch of science which deals with the energy transfer and its effects on properties. So it is mainly the science of energy transfer and its effects on properties. We will discuss about properties. First we see energy, where we will take two forms of energy. One is heat and other is work. Heat is considered as low grade form of energy and work as high grade form of energy. The aim of thermodynamics is to convert this low grade form of energy, which is heat, to high grade form of energy, work, in an efficient manner. So what is the aim of thermodynamics? The aim of thermodynamics is to convert low grade form of energy, heat, into high grade form of energy, work. So we can write this. The aim of thermodynamics is to convert low grade form of energy, which is heat, into high grade form of energy, which is work, in an efficient manner. So the aim of thermodynamics is to convert this heat to work in an efficient way, that is with high efficiency. Now we will study with basic definitions and terms in thermodynamics. So let's start that. System. It is the region in space on which study is focused or concentrated. So system is the region in space on which our study is focused or concentrated. The other term is surrounding. Anything external to the system is known as surrounding. Universe. System plus surrounding is known as universe. So you can write universe equal to system plus surrounding. If it is our system, then our study is based on this system only. Everything external to this system is our surrounding. And if we combine system plus surrounding, this whole as will be considered as universe. So system is on which our study is based. Whatever we want to study, that is considered as system, and other things which is out of the systems are surroundings. And if we combinedly see system plus surrounding, that is called as universe. Boundary. The separation between system and surrounding is known as boundary. So boundary is the separation between system and surrounding. So boundary can be real or imaginary, or it can be fixed or movable. So we will see the examples of boundaries. Boundary. If we let us consider one stationary block. This is our stationary block. So this is considered as our system, and it has its boundary. This is its boundary, and other is surrounding. Since it's a stationary block, so its velocity is 0. This is having fixed or rigid boundary. And it's also having real boundary. On the same block earlier, which we have considered as stationary, this is a system. That block is our system. This is boundary, and this is surrounding. If we give velocity v to this block, then it is moving. So now it's having moving or flexible boundary, and also this is real boundary. Another example of moving boundary is if we consider piston cylinder. See, this is our piston, this is our cylinder, and this is piston cylinder system. If we give velocity, angular velocity omega to this one, so this is our boundary, this is our boundary, and since we have velocity, then this boundary is moving, so it is moving beyond boundary, it is also real boundary. If we consider a flow, and if we choose two section 1, section 2, so this is having fixed boundary. Because the boundary is fixed, we have considered these two sections, so the boundary is fixed here, but these boundaries are imaginary boundary, so and it's also having imaginary boundary because we have not given any physical boundary to it. It is an only imaginary boundary. So we can note one thing. Boundary can be rigid or flexible, and it can be real or imaginary. Now see types of system. So now we will see the types of system, and we will define all these types of system with examples. So we are making a table for this one for its easy understanding. So this is type of system, this is mass transfer, this is energy transfer, and examples. So if we see, first one is open system. It is also called flow system. The other is closed system. It is called non-flow system. And the third one is isolated system. The types of systems are open system, which is flow system, closed system, non-flow system, isolated system. But flow system, in flow systems, mass can transfer, energy can transfer. Example, turbine, compressor, nozzle, diffuser, boilers, closed system, there is no mass transfer, only energy can transfer. Example, thermal power plant, refrigeration plant, piston cylinder excluding valve, isolated system, there is neither mass transfer nor energy transfer. Example, thermoflask, universe. So types of system is open system, that is flow system. In this system, mass can transfer, energy can transfer, that is both mass and energy both can transfer. For example, turbine mass and energy both transfer is there. Compressor, nozzle, diffuser, boiler, these all having mass and energy both transfer. Other is closed system, that is non-flow system. In that system there is no mass transfer, mass cannot transfer in this system, but energy can transfer. For example, thermal power plant, we get energy from thermal power plant. Refrigeration plant, piston cylinder excluding valve, these all are closed system. And isolated system, in isolated system there is neither mass transfer nor energy transfer. For example, thermoflask, there is neither a mass transfer nor energy is transferred. As we put the liquid hot in that, if we consider it an ideal condition, then it will be remain hot if there is no loss. Then in that case it is an isolated system. Universe, it is also an isolated system because there is neither mass transfer nor energy transfer. Here we are considering energy transfer as for heat and work. So these are the types of system. We will continue our lecture in next class.